Morning. My name is Agughalam Ifunanya, and I will be taking today's introduction to statistics. I am a 500 level medical student in the University of Port Harcourt, and I am currently the research assistant in thoracic. I am a budding biostatistician, and I'm involved in health advocacy too, because I believe health is wealth. So these videos will be made in short forms for easy follow-up and comprehension. And I would really love it if you follow me on my train of thoughts and as I teach. Okay, so let's just dive right in. And that's enough for introduction. Introduction to statistics. My name is boldly written below. What is statistics? I believe when we were still in our primary and secondary education, during our basic level education, we did maths, we offered maths, we did multiplication, addition, subtraction, and then when we advanced to secondary level, we did mean, median, and mode, and we were all excelling in our maths and making waves. So this is just like a continuation of the foundation we've already had in our basic level education, and probably introduction of new things that we didn't get introduced to then. So what is statistics? Statistics is defined as a process of collecting, organizing, analyzing, interpreting, and inferring data. So basically, it is just a collection of information from individuals. Say you go to a class of 100 students and you want to assess the performance of these students. So you could use to make decision as to whether we keep this lecturer or we let the lecturer go. So we go to the class, we ask student A what he gets in the exam. He says 56, student B says 75, and so on and so forth. So we collect this data. When we are done collecting the data, we organize the data, imputing it in our softwares, either SPSS or Excel. And this organization can be done by the data collectors, or it can be done by the data analyst. So the data analyst moves forward to analyze this data given to him or her, runs this data through statistical software using statistical tests to get results. He interprets this result. The classical example we already gave, we said, let me see if I can write. Okay, we said, let's say 50, after collecting our data and analyzing it, 50% of students scored 70 and above, then 25 or 35%, 35% of students scored between 50 to 69, and then the remaining percentage is 85. Okay, so the remaining percentage, 15% scored below 50. So this is what our statistical tests, that's the result our statistical test gave us. And so what we infer from these results is that we can infer that the students had a good, that's 50% of the students had a good remark. Then 30%, 35% of students had a satisfactory remark, and only 15% of the class failed the lecturer's course. So what is the decision we are making out of this inference? We're making the decision that we are retaining the lecturer. Okay, so moving forward. Okay, so moving forward, I would like to explain the concept of data and variable, give the definitions of these two entities. So what is data? Data are raw facts and figures to be processed by statistical methods in order to convey meaningful information. It is made up of one or more variables. And what is a variable on the other hand? A variable is simply what is measured or observed. Example, age, occupation are variable in a data. So the term data is more like an umbrella term, and then variables are components of data. You go to a region to perform on-site data collection. There are 256 study participants. You want to collect data on the 256 participants. When you go there, their names, their age, their occupation, their educational qualifications are all what is called a variable. Okay, let me open data I worked on to further explain what I'm trying to explain to you guys. Okay, so if you look at this data showing on the screen, you can see that the variables in this data are timestamp, gender, the geopolitical zone of residence, educational qualification, religion. And this is a data carried out in the region where you want to assess the knowledge and perception of malaria vaccine. So these are the variables they collected. So the whole of this on the screen is called the data, but then each column is called a variable. Moving on. Okay, so we move to types of data. So what are the types of data we have? Data is broadly classified into two. We have the quantitative or numerical data and then the qualitative data. So the quantitative or numerical data just simply quantifies a variable. It asks how much, how many, how often. It's a data that can be quantified. Then a qualitative variable, it's a variable that explains the attributes or characteristics of a variable. So let's say you collect data. My name is a qualitative data in that collection. My age, not my name, my educational qualification, probably my hobbies too, if it's required. It's a qualitative data. So I would also like to mention that there is what is called categorical data, and a quantitative or qualitative data can be categorized depending on the context you set your data. I will explain this further and better when we move to nominal and ordinal data. So what is quantitative data can be further divided into continuous data and discrete data, while the qualitative data can be further divided into nominal data and ordinal data. Moving. So continuous and discrete data. A continuous data is data that has an infinite number between the first and the second digits. To further explain the continuous data, the values usually have a decimal point, and between the first and the second digit, you could have, I give an example here, 1.1, and in between you could have 1.01, 1.001, 1.0001 until infinity. There is an infinite number between the first and the second digits. Height, weight, etc. are all good examples of continuous data. Weight, I could weigh 75.5 kg, another person could weigh 65.8 kg, another person 53.6 kg. Height, I could be 1.73, another person could be 1.07 meters, another person could be, let's say, 5.1 0 meters and all. So that is a continuous data. Then a data is said to be discrete when they are whole numbers. What I mean here is that a number of children, you can have 2.1 number of children. If it's 3 children, you have 3 children. Whether the child has a disability or not, it is a human being and it is 3. So if you have 3 children, you have 3 children. If you have 4 number of shoes, you have 4 number of shoes. The number of scalpels in the surgical department, if it's 10, it's 10. It cannot be 10.1. It cannot be 10.5. It cannot be 10.05. It is whole numbers. Okay, so moving on. So nominal, and since we've explained what continuous and discrete data is, a nominal versus an ordinal data. Nominal data are categorical data in which the values attached to it have meaning or a rank order. Have no meaning, sorry, in which the values attached to it have no meaning or rank order. It is just simply for easy understanding, easy comprehension. Example, sex, male and female in the data collected. There is no rank or order to it. Let's take a research example, like you want to know and the effect of drug, the efficacy of a drug in a previously known diabetic and a new diabetic. So the categorization into previously known diabetic and new diabetic is just for simple comprehension, simple analysis. When you're running your analysis, there is no rank or order to it. So in the ordinal data are categorical data in which there is a rank order and there is an attached meaning to that rank order. A classical example is our BMI, our body mass index. We have the underweight, the normal, the overweight, the obese, and the morbidly obese. And I think our underweight is less than 18.5. Normal weight is 18.5 to 24.9, and then goes on. So a health condition, an obese person will have, it is likely that a normal weight person will not have it. Another example is our stages of cancer. We have stage 1 to 4, and a patient with stage 1 cancer can probably undergo remission at a faster rate than a patient in stage 4 cancer. And then another example is a hypertension. In a hypertension, we have normal hypertension. That's the normal hypertension. Then we have stage 1 hypertension, stage 2 hypertension. The normal value is 140/90 as of now, according to JNC classification. But then as you progress forward, you have stage 1 hypertension, stage 2 hypertension, and hypertensive crisis. So there is a rank, there is a meaning to this rank order. So that is basically what nominal and ordinal data is. In our nominal data, no attached meaning. We are just simply using it for analysis and for easy comprehension, even for the reader. In our ordinal data, we should keep at the back of our mind that there is a meaning attached to this rank order. Okay. All right, our next will be descriptive statistics, and I think I'll pause the video here. So on my next video, we'll start from descriptive statistics. I sincerely hope that the explanations I've given on the introduction to statistics is clear and simple to understand. And when I'm having my live session, if there are further questions that you don't understand, you bring it to the session and then we'll demystify it together. Thank you very much. And I hope that as we progress in the course, as we advance in learning, that you will find statistics interesting the way I do. So, bye.